Okay, if the following symbol denotes the greatest integer function defined in example 9, we want to evaluate the following. Here is the graph from example 9. So we look at the greatest integer function. So up here, if we look at this first one up here, the 4 represents that 4 is included. And then the 4 is not included because it has an open dot. If we look at here, 3 and then 4, 3 is not included, but we know that 3 is and anything in between. So the first thing we want to do for number 1 is we want to evaluate the following. Well, first, for the greatest integer function of x, okay, when it is approaching -2, well, that means that we need to look at that scenario right there. So that means that we have the value of x, okay, which is going to be in between what two values of x? Well, we know that we have -1 up here and we have -2 here, and the closed dot tells us that we can include the -2, but the open dot means that we cannot include the -1, and that's at the value of -2. So we know that the greatest integer function here is equal to -2 if we know that x is in between -2 and -1, including -2. So now we can find what is the limit as x is approaching -2 from the right of the greatest integer function. Well, as it is approaching -2 from the right, then down here, as it is approaching -2 from the right, then we see that it's going to be at -2. So that means that this is equal to the limit as x is approaching -2 from the right of -2 is going to equal the value of -2. In part 2, it says, what is the limit as x is approaching -2 of the greatest integer function? Well, the first thing we need to look at is if it's approaching, we want to find out when is it approaching -2 from the left, because we already know what it is from the right here, so that we can figure out what happens. So what we need to do is we need to extend this line a little bit. Okay, and so there we want to figure out, okay, well, here's -3. And then down here we have -3. And so if we're looking at this, greatest integer function, that means that -3, then we'd have a hole there, and then a solid one there. So if you're coming from -2 on the left, this is the next step below function. So what that tells us is that the value of x is going to be in between -3 and -2, but we're going to include the -3 because we have the closed dot, and here it is less than -2. So that means that when you're looking at the limit as x is approaching -2 from the left, we can see that from the left you'd have to come from the left here, and that's going to equal -3. And again, that's if we have x in between -3 and -2. So what does that tell us? Well, that tells us if we want to find the limit as x is approaching -2 from the left of that greatest integer function, well, that means that this becomes the limit as x is approaching -2 from the left of that number there, which is going to be -3. And so that is a constant, which is -3. So because we have the limit as x is approaching -2 from the right of the integer function is equal to -2, and the limit as x is approaching -2 from the left of the greatest integer function is equal to -3, then we would then say that the limit as x is approaching -2 of the greatest integer function does not exist. Now the limit in part number 3, we want to find out when x is approaching -2.4 of the greatest integer function. And so -2.4 lies between -3 and -2. So the first thing we know there is that if it's in between -3 and -2, we know that it's going to equal -3 here. So we know that the greatest integer function is going to equal -3 for when x is in between -3 and 2. So then we can say that the limit as x is approaching -2.4 of the greatest integer function is equal to the limit as x is approaching -2.4 is -3 on both sides. So if we're going from -2.4, so if we take a look here, if this is where -2.4 is, and if we take a look down here, if we go in from the right and from the left, we're still going to end up at -3. So the answer is -3. And just let me change a couple little words here. This should be not if, this should be for. Okay, part B is asking us to find if n is an integer, evaluate the limit of the greatest integer function when x is approaching n from the left. So let's take a look at the second part when we were approaching the value of n from the left. We can see here that we had our value of -3, and then over here the value was -2. So what that tells us is that this number here is 1 less than, so -2 minus 1 is -3. So therefore, if this is n, then this is n minus 1. So we can say that, according to n, that the greatest integer function is going to equal n minus 1 for when x is in between the following. This is n, and then therefore this is n minus 1. So if we want to take the limit as x is approaching n from the left of the greatest integer function, then that would equal the limit as x is approaching n from the left of n minus 1, which is equal to that integer of n minus 1. Okay, so for part 2, we want to find the limit as x is approaching n from the right of the integer function. So when it was from the right, we said that this value was n, and therefore this was n plus 1. So what that meant was the greatest integer function when we are approaching n from the right was equal to n for when x is greater than or equal to n, which is less than n plus 1. So therefore, if we take the limit as x is approaching n from the right of the greatest integer function, then that would equal the limit as x is approaching n from the right of n, which is equal to n. Now for part C, it's asking us for what values of a does the limit as x approaches a of the greatest integer function exist? Well, we can say that the limit as x approaches a of the greatest integer function is equivalent to, or we can say that equal to, when the value of a is not an integer.